Inequalities, more examples foldable. Here's what it looks like on the other side. All right, so the first ones that we have are word problems, verbal statements. So number 1 says, each week Morning Cafe orders coffee packets that cost $2.50 per packet with a $10 shipping fee. If Morning Cafe does not want to spend more than $554 on coffee packets per week, how many packets could they purchase? So we need to set up an inequality. So we're going to do the cost on the left-hand side. So they cost me $2.50, and then this word here, per, that's a keyword telling you that that is the slope, or that's the number that's attached to the X. We want to know how many of those we can buy, and X represents that. And then we're going to add that to the $10 shipping fee. Now it says they don't want to spend more than. So what I spend needs to be less than or equal to that $554. And now we have an inequality we can solve. So first thing is we move the constants. So we're going to subtract 10 from both sides. So I didn't touch the 250x. The 10's cancel. Sign stays the same. 554 minus 10 is 544. Now we got to get the 250 away from the x. So we're going to divide both sides by the $2.50. X is left, the 250's cancel, the sign stays the same, and then again use your calculator, guys. 544 divided by $2.50 leaves me with 217.6, but I can't buy 0.6 packets, so I have to round that off. It's got to be less than 217.6. So we would round it off to 217. Because if you go up one, then it's going to cost over. You're going to spend over the amount that you can spend. All right, number 2, the sum of 4 consecutive integers is at least 126. What is the set of smallest 4 consecutive integers that fits this situation? So consecutive means in a row, 1, 2, 3, and 4. So when you see problems like this, how you set it up, my first number is going to be x, and then we're talking about the sum. So I'm going to add it to other digits. So I'm going to add this 2. Okay, so if x is my first number, to get to my next consecutive number, I would do x plus 1. My next one would be x plus 2. And then my final one would be x plus 3. So again, think if x is 1, 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4. 1, 2, 3, 4. Now it has to be at least, which means it can be greater than or equal to 126. So at the least it has to be 126, but it can be more than. So now what I can do is I can combine like terms. So all my x's can go together. So if I have 4 x's, I can write that as 4x. And then all my constants, I can combine those terms. So plus 1, plus 2, plus 3. 1 plus 2 plus 3 gives me a 6. And so always simplify your equations and inequalities before you try to solve. All right, so we move the constant first by subtracting 6 from both sides. I didn't touch the 4x. The 6's cancel. 126 minus 6 is 120. Now I've got to get the 4 away from the x, so I divide, do the opposite. So the 4's cancel. 120 divided by 4 is 30. So x, my first number, is 30. So my 4 consecutive integers would be 30, 31, 32, 33. They're all in a row. If I plug that x, that 30 in, 30 plus 1 is 31. 30 plus 2 is 32. 30 plus 3 is 33. All right, on the next side, or the next row, we are looking at graphs. So first thing that we're going to do is we are going to label this inequality. And what I mean by label is we're going to give each side a name. So the first side here, we're going to call y1. The second side here, we're going to call y2. So left side, y1, greater than or equal to the right side, which we're going to call y2. Now we can solve this. So first off, we have to simplify. So we're going to combine like terms. 6 times x is 6x, 6 times 2 is 12, and then tack that minus 4x to the end. Combine like terms. So 6x and negative 4x can combine. So remember, in your calculator, all you would do would be 6 plus a negative 4, or 6 minus 4 would be the same. So 6x minus 4x is 2x. We didn't do anything to the 12. Keep the inequality sign. Right-hand side stays the same. Now I can solve this. So I'm going to subtract 12 from both sides. Eight minus 12 is a negative 4. Then we got to move this 2, so I'm going to divide both sides by 2. 2's cancel. X is greater than or equal to negative 2. Sorry, that's that sign, greater than or equal to. All right, now we have to graph these. And we have not graphed a lot of equations, and you might not have done this last year. So the first one we're going to do is y1. So y1 was this left-hand side. Now, I don't want this form. I want where I simplified it, the 2x plus 12. 2x plus 12 is the same as 6, open parentheses, x plus 2. And then the other side, y2, was just an 8. All right, 2x plus 12 means that that line is going to cross the y-axis at 12. But my y-axis does not go that far. So what I'm going to do is I'm going to plug some numbers in that I know will work. So I'm going to plug, let's plug a negative 7 in for x. Okay? Let's see here. So we said 2x plus 12. So what I can do, I can plug any value in there for x. Okay? And then in my calculator, I just type it in just like that. Negative 7 plus 12. And I get negative 2. So that means I've got a point. If x is negative 7, the y is negative 2. Another point that I can use, let's do negative 2, maybe? So 2x plus 12, this time I'm going to plug, let's plug a negative 2 in for that x. So 2 times negative 2 plus 12 gives me an 8, which means if x is at negative 2, y is at negative, or y is at positive 8. So these are 2 points that I can graph. Okay? So on this graph, I'm going to put a point at negative 7, negative 2, so right there, and then at negative 2, positive 8. Remember, when you're graphing any point, x, y, you always move left or right first. So move along your x-axis and then up or down. Now all I need are 2 points, and I can graph the equation of a line. So on a graph, that line represents the same thing as this equation. Now the next one, 8, y equals 8. All that means is you go up to 8 on the y-axis, and it's going to be a solid line. So a nice, pretty horizontal line. All right, so the solution on a coordinate plane like this, you're going to find the point at which y1 is greater than or equal to y2. So y1 was this line, and then this was y2. So the point at which y1 is greater than is above that horizontal line. So any x, and I'm going to use my highlighter, and this is something that we're going to do more later, so don't worry if it's confusing to you now. All you need to know is how to solve these things and get a solution. So anywhere along that line, any x that's along that line, so x is 1, x is 2, if I plug those in, to this equation, my answer is going to be greater than 8. But again, just showing you how to graph these inequalities. All right, the last ones we're going to do are special cases. All right, we need to solve this thing. I'm just going to rewrite it over here. All right, so we're going to move the 7. Actually, let's put the x's together first. That should be our first step. So if I subtract 4x from both sides, 4x minus 4x is a 0. Sign stays the same. Didn't touch the negative 7. So this says 0 is less than or equal to negative 7. That is not a true statement. 0 is greater than negative 7. So 0 is never less than or equal to negative 7. Therefore, this is never true. And the answer is the empty set, and you draw that 0 with a line through it. That represents an empty set, an empty or a non-existent answer. The graph would show parallel lines where y1 is never less than or equal to y2. So if we would graph these, and I'm not going to graph these exact, okay? I want you to see what they would look like. Actually, I'm going to graph these. 4x, I can put a point at 1, 4, and 2, 8. Again, you don't have to worry about graphing these. I wanted to expose you to it a little bit. So 4x would look like that on a graph. So move that mouse out of the way. And then the other one, 1, 2, 3, 4, 1, 2. I think I did that right. Nope. 1, 2, 3, 4 over 1. That should be the point. So when I graph them, if I'm looking at a graph and they're not perfect, but if the lines are parallel, that means there's never going to be a solution. There's never going to be an answer. Okay? So just like our other special cases, the infinite, the no solution, this is a no solution. Okay? All right, the next one, 5x plus 7 is greater than 5x minus 8. So on this one, if I move my x's, 5x minus 5x cancels, so I'm left with a 7. Inequality stays the same. 5x minus 5x, sorry it froze, cancels, minus 8. This says 7 is greater than negative 8. So 7 is always greater than negative 8. Therefore, this is true for all real numbers. So this would be infinite solutions. So remember, if our final solution here isn't x is greater than a number, x is less than a number, if it's just two numbers and the statement is true, that's the infinite solution. So the graph shows parallel lines where y1 is always greater than y2. So that's it for tonight's notes. We will work on the assignment during class tomorrow.